This video is going to give you some tips on what to expect in the tutoring center, and it's going to just give you some good ideas so that you can help the people who are coming in, you can help them understand the material more as they start working through this. So the biggest tip that I have to offer is to think out loud. And this is really one of those concepts that's not practiced as much as it should be. In schools, outside of school, you should be thinking out loud. When you're working these math problems and you start taking shortcuts, if you're not saying what it is you're doing, then people are going to get confused. For example, if I were to write down something like f of x equals 7x squared, and if you haven't taken calculus and I say, okay, the first derivative is 14x, you have no idea how I've gotten there, assuming you haven't taken calculus. But by thinking out loud, here's how I would go through the process. I'd say, okay, f of x is 7x squared. And when I take the first derivative, which is nothing more than the slope, that is the derivative. It's the equation of the slope of that guy right there. When I take the derivative, I know I need to multiply this guy down in front, and 7 times 2 is 14, and after I multiply it down, then I should subtract 1 off of the power on top. And 2 minus 1 is 1, and since I don't have to write the 1, that's the first derivative. Yeah, it's longer to go that way, but that made so much more sense when I explained it. And it's not that hard. All you had to do is justify each step that you take in math. If you really want to make it, go back to some basic stuff, if I have 3 plus 5 and I were to think out loud while I was doing this, if it was like for early elementary education or something like that, I would do something along the lines of this. Okay, if I have 3, that's represented with something like this. And I want to combine that with 5. And 5 would be something like this. And when I combine 3 and 5, I want to know how many are there in the end altogether. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 objects in the end, which I'm going to not get ahead of myself and write 8. That's what thinking loud is. That's where you justify every single step you take. And you'll adjust how much thinking out loud you do and what's relevant based on their level that they're in. Obviously, you would never do this to someone coming in the tutoring center because they should know this by now. If they don't, there's going to be worse problems in their life than worrying about passing their 015 class. So that's the first tip. Second tip as we go through this is to go back to the basics. Yeah, you know why. Let me write that down. Let me write that down real quick. So go back to the basics. Whenever they're confused, if you go back to the raw essentials, the basics, it will make more sense. So going back to that example I started, you know that 2x squared plus 3x squared is 5x squared. You know that. You've done it 101 times. You've done it. It's familiar to you. My question for you is why is that is. That's what it means to go back to the basics. You should always answer the question why. If I were to try and describe this myself, well, I would say I have 2 times x squared and 3 times x squared. And since x squared, that's just a name. I could have easily called that I don't know, apples. How about that? So if I have 2 groups of, that's what multiply means, is groups of. If I had 2 groups of apples combined with 3 groups of apples, how many apples do I have altogether? And when I word it this way, it makes sense. I had to have 5 groups of apples. Well, what's in the name? I just called x squared apples. I'm saying it's just some unknown value. And as long as they match, I couldn't add apples and bananas, but as long as they match, you can do that. That's what it means to go back to the basics, to really understand why it is you can do what it is you're doing. Let's see, some other tips. You should, when you're stuck, ask for a consult. Get help. If you ask for help from the other tutors, or maybe even some other people there at the tutoring center if they have time, you're going to be surprised at how much they're going to see that you just don't. I mean, even the most brilliant of minds have to ask for a consult periodically. It just happens. Don't pretend that you know it when you don't. Just say, I'm not sure, let me check with some of the other tutors. Very useful piece of information. Let's see. This one's important here. It says, where possible, try to mirror the process that the 2D is already applying. If that can be a little hard to do because it requires you to understand a lot of processes, but you should copy the tutor. Not the tutor, the 2D. Copy the 2D. In the sense that if they're doing something a certain way, you should match that. Trying to change it up on them, unless they're doing something wrong, it's going to be confusing. So if they've started a process, if they have x to the negative second, and what they're doing is just moving it underneath, as long as they're doing it right and you feel they're understanding it, and try to mirror that process in the future. Okay? So some other tips. Let's see. If they don't, this is probably the most important one. If they don't understand a difficult concept, get rid of the algebra. You're going to be surprised how useful this is. Get rid of the algebra, just meaning the variables. Get rid of the variables. And what I mean by that is this. Let's say I have x plus 2 times x plus 1. And you know this when distributed together, this is what would end up happening. You'd have 1x and 2x is a 3x, and then your 2 there at the end. They may not like that. And if that happens, it's because of those little pesky guys right there. A lot of people are very concrete thinkers. It means they have a hard time putting letters inside with math. In their mind, letters and math should be two completely separate objects. But you just have to remind them that this is just a placeholder, because we really don't like looking at blanks. If I got rid of those, I mean, that's really unpleasant to look at and we don't know what to do with it. So we just put letters in place there. But what I would do is get rid of the variables, meaning, okay, you pick whatever number you want for x. I really don't care what it is. Preferably not 0, you know, and so let's say they pick 4. And if they pick an extreme number, you may want them to pick something that is not as extreme, because you're going to demonstrate what happens here. All right, we can simplify this, because now I know what x is. Okay, I could combine those together. 4 plus 2, that gives me a 6, and 4 plus 1, that gives me a 5, and I know that 6 times 5 is 30. What I want to demonstrate, though, is how this process right here can be transferred using known numbers. So I would begin by saying, okay, let's just apply the FOILing process. I would do my first terms, meaning 4 times 4 is 16, and 4 times 1 is 4, and 2 times 4 is 8, and 2 times 1 is 2. And when I add those all together, you can even have a little fun with it and just go, okay, if I add these all together, I go, real quick, I would get 30, since you know obviously it has to be the same thing. Checking it, you would have 10, and 20 does give you 30. So that's what it means to get rid of the variables.